All right, here's going to be a review help for Chapter 4B review for Algebra 2 CP. I want to start with question 1 and just talk about how to graph a quadratic equation. All right, so the way that I teach my students how to graph is by first finding the vertex. And the way that you find the vertex is real simple. It's a simple formula. It's the xy coordinate negative b over 2a and then f of negative b over 2a. And a lot of students have trouble with that second part. What is f of negative b over 2a? What is that? Essentially, all that is what you get when you plug your x value into the equation. Okay, so I'm going to show you how that looks for this particular question here. So for this particular problem, a is 3, b is negative 6, and c is 1. And if you're like, what? Well, quadratic equations have the form ax squared plus bx plus c. Okay, so therefore a is 3, b is negative 6, c is 1. So therefore, when I'm finding the vertex, the negative b over 2a part, all I got to do is take negative 6. So negative 6 over 2 times 3. So it's 6 over 6, which is 1. So the x coordinate of my vertex is 1. The y coordinate is what I get when I plug in 1 into the equation. So here's your f of negative b over 2a. This is what you're actually doing. So all I do is plug it in. So my x coordinate is 1. My y coordinate is what I get when I plug it in to the equation. So what that ends up giving me is 3 times 1 squared is 3 minus 6 plus 1. 3 minus 6 is negative 3 plus 1 is negative 2. So my y coordinate is negative 2. So my xy vertex is 1, negative 2. So the first thing I do, so the next step is from the vertex, the leading coefficient gives me the next points. And it's not, and the leading coefficient doesn't give me a bunch of points. It just gives me the next two, and it gives me the shape of my quadratic equation. Okay, some teachers might have you put it in your calculator, look at the table, find the vertex from the symmetry of the table, and actually we've looked at that too. But for the purposes of this one, I'm gonna kind of leave the calculator out of it and just graph it based off the fact that I know that the leading coefficient, your 3 right here, tells you the next 2 points. So my vertex at 1, negative 2 is right here. Okay? From there, I see that the lead coefficient is 3. So it's positive, so the graph's going to go up. And I know that a quadratic graph is a parabola. It's like a U shape. So I know that the next 2 points are going to be up 3. Okay? And it's not going to be like a straight slope thing. I'm not saying that. I just know that the next 2 points are up 3 because 1 squared is 1. So the next point is going to be 3 times 1. 3, if you were graphing it like normal at the point 0, 0. And if that doesn't make sense, just kind of understand the lead coefficient tells you what direction you're going. And actually that gives me a decent enough graph, and that tells me what the graph's going to look like. If you wanted to, you could plug that into your graph or into your equation, your y1, look at your table, and find the other points that way. All right, so the axis of symmetry is always the x value of my vertex. In this case, x equals negative 1. The domain and range. The domain is all the values that x can and all the values that are defined for the function. Okay, if a function is undefined at a certain value, then that value is not part of the domain. In this particular case, there's nothing that you can't plug in to this particular equation. Everything's fine. Negatives, positives, anything. So therefore, the domain is all reals. However, there's a certain number of y values that do not come into play. So when I look at y values, I think like domain is, well, every x value is taken into account. Y values start at negative 2, and then the graph goes up. So the range for this particular graph starts at negative 2 and goes up. So if I were to graph that, it's like an inequality, it'd be y is greater than or equal to negative 2. So there's my range. Okay, so again, domain x values, range y values. Domain, no restrictions. Range, however, again, since the graph is strictly going up, you're going to get a range of y greater than or equal to negative 2, because the value negative 2 is part of the graph. Okay? Next question is number 4. Number 4 says, use completing the square to write each equation in vertex form. So looking at that, it's a very straightforward process. The way you do this is by kind of ignoring that 3. So my first step is I'm gonna add something here I'm going to keep my 3 there, and then I'm going to subtract the same thing. Because you can't just add something to an equation. You have to take into account that that's not legal. You got to subtract it as well. So what I ask myself here is, what value completes the square? Okay? What I mean by complete the square is I want to write this thing as some binomial to the second power. What that's going to enable me to do then is have the equation in vertex form. So what I ask myself is, okay, what value completes the square? Well, the value, the straightforward formula, it's always going to be essentially b over 2 squared. Okay? Well, what's b? B is negative 4. So this is going to be negative 4 over 2 squared. Negative 4 over 2 is negative 2. Squared is 4. So the value that completes the square is 4. And that's going to be your basically, and I always ask myself, like, half the value with x squared. And that's because if I look at that, I can now break that down into x minus 2 times x minus 2, or x minus 2 squared. But I can't just add 4. I have to also subtract it. So now, this part of my equation kind of stands alone. And I'm going to rewrite that as x minus 2 squared. Not x minus 4 squared. X minus 4 squared would be something different. It's x minus 2. It's the b over 2 goes in there. And then 3 minus 4 is negative 1. So when my equation's in vertex form, the vertex is right there. So if you were asking yourself, what would the vertex be? Okay. By putting it into vertex form, I find the vertex is going to be 2, negative 1. Opposite of what's inside, exactly what's outside. Okay. Not necessary to find the vertex. It didn't ask me for that. It's asking me for vertex form, but that's how you would do it. So that's completing the square to put an equation in vertex form. That's a skill you need to know. All right, next question we'll look at is number 8. Number 8 says graph and answer the questions below. Okay, so essentially what you're going to do first is just graph this. And you're going to graph it as you would graph anything. I'm going to find the vertex. I'm going to look at the lead coefficient. I'm going to graph it like it's y equals 2x squared minus 8x minus 1. I'm not going to think of it as an inequality, and I'm only going to think of it as an inequality when I'm ready to draw my line as dotted or solid. So in this particular case, same concept. I'm finding the x value of the vertex, negative b over 2a. So it's negative 8 over 2 times a. A is 2, so it's 8 over 4. So the x value of my vertex was 2. Now I got to find the y value of my vertex. The y value of my vertex is what I get when I plug 2 in. All right, so I get 2 times 2 squared is 8, minus negative 8 times 2. So minus 8 times 2 is negative 16. So it's 8 minus 16. So it's negative 8 minus 1 is negative 9. So negative 9 is the y value of my vertex. So my vertex turns out to be 2, negative 9. And just like we said before, I start there. So 2, negative 9. And then I look at the lead coefficient. In this case, it's 2. So my lead coefficient being 2 means I go up 2 to the left and the right, and I don't go down because it's a positive lead coefficient. And now the question says y is less than the graph, so it's not less than or equal to, so I'm going to graph a dotted line at this point. So I'm going to graph my dotted line. And make sure it looks like a U. Don't draw a V at this point. A lot of students like to draw a V. A V is an absolute value graph. This is not absolute value. This is a quadratic. And if you know, like I said, if you want to get more points, go to your table, you'll type the equation into y1 and look at your table. All right, so now the question is, like, it says y is less than the graph. So what that means is that what I actually have here are all the points less than the graph. And if you're like, how did you know the graph there? Well, I like to plot a point. And from this particular graph, it looks as if 0, 0 is inside. So I could plot 0, 0 and see if 0, 0 works. What that means is I'm going to plug 0 for y, 0 for x. And what I see is that these go away, but basically it says 0 is less than negative 1. Is that true? Is 0 less than negative 1? The answer is no. So what that means is the point 0, 0 is not part of the solution. Okay? So that's another way you can make sure. But if you look at the fact that y is less than, you're going to graph below the graph. Okay? So now the 3 questions they ask. The first thing it says graph, then answer the question. So I graphed it. Let's answer these questions. It says describe the portion of the graph that represents the solution. All right, so that would just be the shaded area below the graph. Okay? B, is the point negative 2, 4 a solution? So I find negative 2, 4. So negative 2, 4. Is negative 2, 4 a solution to the inequality? Explain. So what I'm going to actually figure out, I'm going to plug it in to the inequality and see what happens. So the inequality y is less than 2x squared minus 8x minus 1. So I'm going to plug the point in and see what happens. See if actually I get a true statement or a false statement. So minus 8 times negative 2 minus 1. So I get 4 is less than, so I'm bringing this down here. So 4 is less than 8. So negative 2 squared is 4. 4 times 2 is 8. Plus 16 minus 1. So negative 8 minus times, so okay, so I get 4 is less than 24 minus 1. 4 is less than 23. Is that true? And if the answer is yes, then you know it in fact is true. So in this particular case, I do get a true statement. So this one would say yes. And the reasoning would be right here. Okay, explain. Well, explain is right here, the work that you showed right there. Okay. And then lastly, what is the vertex of this parabola? Well, we found that in order to graph it. So we found that before we did anything else. So that would be how you do question 8. And again, it's an inequality. It's not an equation. So you got to take into account that you have a shaded area as your answer. Is the line solid or dotted? And then think about it like that. All right, number 10. This is write the equation in standard form. So we took an equation that was in standard form and put it in vertex form. So here's vertex form. I want to write it in standard form. So the tips I'm giving you are get rid of the parentheses, make the equation. Ax squared plus bx plus c. It says watch out though. Do not distribute a number in front of the parentheses until foiling the second power. So what I mean by that is students will sometimes distribute that too. The answer is like you can't do that. That's multiplication. Multiplication does not come before exponents. So when I do this one, I FOIL first. Okay, so it's x plus 3 times x plus 3. I leave the 2 alone still. That's x squared plus 3x plus 3x plus 9. Okay, again, I'm still leaving the 2 alone. I'm continuing to combine like terms inside. Now, at this point, I've taken care of the exponents. Now I can distribute that 2. Okay, and get rid of these parentheses. So y equals 2x squared plus 12x plus 18 minus 5. And then the last thing I have to do is just combine my like terms. I only got 2 like terms of constants right here. So 18 minus 5 is 13. So what I just did is I took the equation that was in vertex form and I put it into standard form, ax squared plus bx plus c. Okay? And then the last one I want to talk about is number 12. Number 12 says, although a football field appears flat, the surface is actually shaped like a parabola so that a rain runs off both sides. A cross-section of a field with a synthetic turn can be modeled by the equation y equals negative 0.000234x times x minus 160, where x and y are measured in feet. What is the field's width? Okay, so what you're asking there is like, oh boy, right? You're worried about it, you're freaking out. But essentially, when you look at these word problems, the big thing you want to be able to do is to find the vertex. Okay, that's essentially what you want. So it says, what's the field's width? Well, the field's width would be twice the x value of the vertex. And what's the maximum height of the field surface would be the y value of the vertex. So if this equation is right here, I just need to find the vertex of that equation. Okay, so I'm just actually going to do the same thing that I did before, negative b over 2a, and then plug what I get into the equation. I might need my calculator for this one because the numbers are kind of funky, but it's essentially the same thing. So my equation, I'm going to distribute here. So I'm going to get negative 0.000234 x squared. And then I distributed my number here. And then I'm going to distribute it to the negative 160. So in my calculator, I'm going to take negative 0.000234 times negative 160 and see what that comes out as. All right, so that's plus, what was it, 0.03744. And you got to make sure you knew that there was an x on it because there was an x on the negative 0.000234x times negative 160 would give me that. So now my b value is right here. So when I'm doing my vertex, x again being negative b over 2a, was negative 0.03744 over 2 times a, which is negative 0.000234. Okay? So I'm going to do that in my calculator. So I get negative that divided by, and I'm going to take 2 times negative 0.000234. Okay, and just like I said, be systematic, like I'm saying all these times, be systematic about it, and you should be able to get the answer, which actually comes out kind of pretty, which is 80. So that's kind of nice, 80 feet, or whatever it is. It says feet, yeah, measured in feet. So x is 80, so now y equals negative 0.000234, 80 squared plus 0.03744 times 80. And you're looking at this question, I'm sure you're like, oh my gosh, this is so difficult. The only reason this is difficult is because there's crazy amounts of decimals. If these numbers were more simple, I think this question would be way easier to kind of see what you're doing. But anyways, I'm going to keep going. I'm going to find out what this is. So it's negative 0.000234 times 80 squared. All right. I forgot my decimal point, I think. So negative 0.000234 times 80 squared plus 0.03744 times 80. Okay, so there's the equation that's going to give me my y value. So that's 1.49, what was it again? 1.4976. Okay, so 1.4976 feet. Okay, so these are both in feet. And now what I just found essentially is the vertex. So I got the x value is 80, 1.4976 is the y coordinate. So what's the field's width? Well, from here to here is 80, right? Think about x value, that's the horizontal distance. So if I'm thinking about that being right in the middle, which a vertex is, the vertex of a parabola is right in the middle, then I know that's 80 plus 80, so the field's width would actually be 160 feet. Half the field's width is 80, so don't say 80. 80 is like how far it is for half the field. All right, and then what is the maximum height? Well, that is just the y value that I found. So 1.4976 feet. And that would be how you do that question. Once again, seems difficult, but if the numbers were easier to kind of work with, I think you'd find that question is actually pretty easy, because all it's asking you to do is find the vertex and interpret it a little bit. Okay, so I hope this helps you ace your chapter test.